Kernel SHAP has this one tiny, well, actually, it's a massive hidden flaw.
So the whole problem boils down to this one really bad assumption. See, to figure out how important each player is, the method basically runs a bunch of what-if scenarios. It shuffles your data around, but, and this is the key part, it assumes every piece of your data, like your income and your age, are totally unrelated, that they have nothing to do with each other.
And we all know that's just not true. That's not how the world works at all. Of course your age is related to how many years you've been working. It's just common sense. These things are connected, they're correlated. They aren't independent islands of data. So what happens is, the model ends up making judgments based on completely nonsensical combinations of data. The researchers who wrote the paper we're looking at put it perfectly. They said the method, quote, suffers from inclusion of predictions based on unrealistic data instances when features are correlated.
So here's a way to think about it. The algorithm is essentially inventing fantasy people to run its tests. It's asking the AI, hey, what would you decide about a 25-year-old who has 30 years of work experience? It's absurd, right? And the answers it gets from these fantasy scenarios are then used to explain a real decision about you. That's a recipe for a really unreliable, potentially misleading explanation.
Okay, so we've got this big problem. The method is living in a fantasy world. So what's the fix? Force the explanation to live in the real world.
It's pretty straightforward. Instead of just pretending all your data points are separate, the new method actually learns how they're connected. It looks at the real data and figures out the real relationships. And that one change keeps the whole thing grounded in reality. So think about the process. Step 1, instead of making stuff up, the new approach learns the rules from the actual data. Step 2, when it runs its what-if scenarios, it only creates combinations that are actually possible, people who could really exist. The result? You get an explanation that is, as the researchers call it, true to the data.
Okay, that all sounds great in theory, but does it actually work? Is it really better? Well, let's take a look at the proof, because the pictures tell a pretty convincing story.
This image says it all, really. Okay, so all those black dots, that's the real data, the ground truth. Now look at the red dots. That's the old method. See how they're just scattered everywhere and making up all this fantasy data? But the turquoise dots, that's the new method. They're hugging the pattern of the real data. They're realistic. That's a foundation you can actually trust. And if you're more of a numbers person, check out this chart. The researchers measured something called explanation error, which is just a fancy way of saying how wrong the explanation is. Look at that first bar for the original method. The error is huge. Now look at the bar for the true to the data method. It's way, way lower. The explanations are just flat out more accurate.
Just to put a number on it, in one of their main tests, this new approach was over 82% more accurate.